welcome back. We are going to take a look at electron configurations, which just means how the electrons are arranged in the atom, how the electrons are arranged within the atom. And there's a few things that we need to know. We need to know the order of our energy levels and sublevels and how many electrons will fit in each sublevel. So remember, we have energy levels 1 through 7. And we have sublevels S, P, D, and F. And the energy level is equal to the number of sublevels that we have. So for energy level 1, there's one sublevel, S. For energy level 2, there's two sublevels, S and P. For energy level 3, there's three sublevels, S, P, D, and so on and so forth. So we need to know how our sublevels and energy levels are arranged from lowest energy to highest energy. There's a really easy way to know that, and that's by using the Aufbau diagram. The Aufbau diagram shows all of the energy levels and sublevels in order of least amount of energy to the highest amount of energy. So 1s would be the lowest amount of energy, all the way up to 7H, which I don't even have here because we don't use it, which would be the highest energy sublevel. So the Aufbau diagram is a really easy way to make sure that you have all of your energy levels and sublevels in order. So you can write this on any homework or test. That's really easy to memorize. You just write your numbers in order with their sublevels, and you draw your diagonal lines moving upwards. So what this means is that we'll fill 1s first, then we'll fill the 2s sublevel, then 2p, and then 3s, and then 3p, and then 4s, and so on. The last piece of information we need to know in order to be successful is how many electrons will fit in each of these sublevels. So in S, we can fit 2 electrons. In P, we can fit 6 electrons. In D, we can fit 10. And in F, we can fit up to 14 electrons. So now that we know that information, let's try and write out an electron configuration. Let's start with sodium. Sodium, if we look on the periodic table, has the atomic number of 11, which means there's 11 protons and 11 electrons. So how could we write the electron configuration for sodium? Remember, we're just writing out how the electrons are arranged within the atom. So we're going to start with our Aufbau diagram at 1s. We can fit 2 electrons in 1s. So I'm going to put 1s with an exponent of 2. And that stands for 2 electrons can fit in 1s. I need to account for 11 electrons, so I need to keep writing out my configuration. Next, we move up our Aufbau diagram to 2s. And again, S can fit 2 electrons. Then we move up our Aufbau diagram to 2p. And P can fit 6 electrons, so I'm going to put a 6 there. And let's count how many electrons we've accounted for. 2 plus 2 is 4, plus 6 is 10. So we need one more electron. So I'm going to follow my Aufbau diagram. After 2p, I need to fill 3s. And 3s can hold 2 electrons, but I only have 1 left. So I'm going to write 3s1. So I have 1s2, 2s2, 2p6, and 3s1. And that accounts for all 11 of my electrons in sodium. Let's try another example. Let's look at argon. Argon has 18 electrons, so our configuration should be a little bit longer than sodium. Again, I'm going to start with 1s, 2, 2s can fit 2, 2p can fit 6 electrons, 3s can fit 2 electrons, and let's double check. We have 2 plus 2 plus 6 is 10, plus 2 is 12. We need 18 electrons, so I need 6 more. Following the Aufbau diagram, after 3s, I fill 3p. And 3p can hold 6 electrons, and that's exactly what I need. So 1s2, 2s2, 2p6, 3s2, and 3p6. And remember, the electrons in the highest energy level are called the valence electrons. So sodium would have 1 valence electron. Argon would have 8 valence electrons because I have 3s2 and 3p6. And the valence electrons are in the highest overall energy level, and 3 is the highest energy level. Let's try one more example. Let's try a harder one. Let's look at bromine. Bromine is number 35 on the periodic table, so we need to account for 35 electrons. So we have 1s2, 2s2, 2p6, 3s2, 3p6. After 3p, we go to 4s2. After 4s, we can start filling 3d. D can hold up to 10 electrons, and let's count how many we have so far. 2 plus 2 plus 6, that's 10, plus 2 is 12, plus 6, 18, plus 2 is 20. I need to get to 35, so I can completely fill my 3d orbital with 10, which means now I have 30 electrons. I need 5 more. If we look on the Aufbau diagram, after 3d, we fill 4p. And I'm only going to put 5 there. Even though p can hold 6, I only need 5. So let's double check. 2 plus 2 plus 6 is 10. 2 plus 2 plus 6 is 10. Plus 10 plus 5 is 35 electrons in total. And we can see how many valence electrons there are. We have 4s2 and 4p5. So if we add both of those sublevels together, we have a total of 7 valence electrons in bromine. And there's an easier way to write the longer electron configurations using something called the noble gas configuration or shorthand configuration. And I'll post another video on how to do that on my channel. And there's an even easier way to write the electron configuration just using the blocks of the periodic table. And I'll post a video on how to do that as well. Thank you for watching. I hope this was helpful. Thank you so much for stopping by.